Yes, in this video, we are going to discuss about the graph traversal. When we talk about a graphs, one important thing is how we visit or explore all the nodes and edges. This process is called graph traversal. There are two main ways to do this. The first is birth first search, or in a short form BFS. Here we start from a node and explore all its neighbors first, then we move on to the neighbors of those neighbors. It's like exploring the graph level by level, going wide before going deep. The second way is depth first search, or in a short form DFS. Both BFS and BFS help us to understand how a graph is connected and are useful for things like finding a path or checking if everything is reachable. Let me explain how the birth first search or BFS works step by step. First, we create a queue with a size equal to the total number of vertices in the graph. This queue helps us keep track of the nodes we need to visit. Next, we pick any vertex to start with. We mark it as visited and put it into the queue. Then we look at the vertex at the front of the queue. We visit all its neighbors that have not been visited yet, mark them as visited, and then add to the queue. If there are no more new neighbors to visit from that front vertex, we remove it from the queue. We keep repeating this process, visiting neighbors and removing visitor nodes until the queue is empty. When the queue finally becomes empty, it means we have visited all reachable vertices. At this point, we can produce a spanning tree by removing any edges that are not used during the traversal. This picture shows how the BFS explores every node in a graph. We start at the node A. BFS visits A and adds its neighbors B, D, E to the queue. Next, BFS visits B and adds B's neighbor C to the queue. And then BFS visits D and adds G. After that, it visits E and adds F. Next, it visits C, which has no new neighbors, and then it visits G and adds H to the queue. After that, BFS visits F, which doesn't have any new neighbors. Then BFS visits H and adds its neighbor I to the new. Finally, it visits I, which has also no new neighbors. By following this order, BFS visits all the nodes A, B, C, D, E, F, G, H and I one by one and then by level. This way, BFS covers the whole graph and shows the shortest path to each node. I hope this gives a clear idea of how the BFS help us to navigate through the graph easily. Thank you.